Guys, welcome to SUBU Medicine, and this is Endocrinology. So today we'll be discussing about the glucagon. Okay, so that's what we'll be focusing on. So here, look at the structures right here. So you guys know this now, right? By now, this is gonna be your what? Pancreas, right? This is what it is. And then this is a cell that I drew here. Okay, these cells, it's the endocrine cells. Okay, and these endocrine cells are called your pancreatic island or islet of Langerhans, right? And if you see this right here, these are beta cells, which are centrally located, okay? That's what, and these beta cells are the one that secretes, the synthesize your insulin, your C-peptide and amylin, okay? And right here, look at this, peripherally located are these alpha cells, and these are the alpha cells who are gonna produce what? Glucagon, right? Not only they produce the glucagon, but they also produce, what is this called? The GRPP. What does GRPP mean? We'll talk about this, I'll tell you about this. And then, not only that, the islet of Langerhans also contains that this in orange, these are called delta cells. And this delta cell releases somatostatin. And these somatostatins are what? They will inhibit locally these secretions of your insulin and the glucagon. That's what they do. Okay, and then what about this F cell? These F cells are your pancreatic polypeptide in this green, and they secrete. Okay, this F cell secretes pancreatic polypeptide, and what it does, it inhibits your somatostatin. Okay, but today what we're focusing here is that this alpha cells right here. Okay, so this is a glucagon, right? And you guys know the glucagon is what? It's a peptide hormone, right? That's why you guys know this, And the glucagon is what? It's a catabolic hormone. You guys know this. But what is the GRPP means, okay? There's also the producer. This GRPP is, okay, it is called your glycine, okay, related pancreatic peptide. That's what it is. That's what it is. And this is just has a glucagon. It just has, just like, glucagon. This works, acts like a glucagon, okay? It has a similar functions of glucagon, okay? This GRPP. Just wanted to let you know. But anyways, now we're going to talk about, how does the glucagon get synthesized, and when does glucagon get synthesized, and what is actions into the peripheral tissue. That's what we're going to discuss about it, okay? So you guys know this, okay? That this glucagon is what? It's a catabolic hormone, right? It's a catabolic hormone. It's a catabolic peptide hormone, right? It has like composed of about 29 amino acids, right? So basically, this catabolic hormone, peptide hormone, this glucagon, it's act as an antagonistic for insulin, because insulin, you guys know this. What is insulin? Insulin, you guys know this by now, it's an anabolic hormone, right? That's what it is. Primarily, it's an anabolic hormone. That's what it does, right? So this glucagon has an antagonistic effect on the insulin, right? But today we're primarily focusing on the actions or effect of the glucagon. That's what we'll be focusing on. And look at these cells right here, okay? This is the alpha cells I do, okay? So what is happening here that we talk about, right? So, the synthesis of glucagon takes place, okay, whenever there is low level of glucose, okay, in your, let's say in your plasma. Look at this axis of fluid. So there is a what? There's a low level of plasma level of glucose, okay? That's what it is. Or whenever you take, let's say, high amount of amino acids, especially that amino acid that contains, okay, the arginine, okay, let's say increased level of amino acids, especially your arginine. Okay, and remember, arginine is, if you remember from the biochemistry, arginine is what? It's a positively charged amino acid. And your alanine, okay? And alanine is your non-polar amino acids, okay? So whenever there is a low level of glucose, or we call this as a hypoglycemia, okay? Then, we want glucagon. We want glucagon in circulation. Because what? Because the plasma level of glucose is falling down. We want plasma level, we want to increase the glucose level, right? So how does the glucagon, brings the plasma level of glucose, okay? That's what we'll discuss about. Now, Not only this, okay, whenever, let's say, whenever you have abundant amount of like your CCK also releases, CCK has a receptors, okay, in alpha cells, they also synthesize the release of a glucagon, okay, so high level of, let's say, CCK, okay. These are the some of the effect, these are some of those causes to release or synthesize more glucagon, okay. Primarily, you should remember is that whenever you have a low level of glucose, okay, that is the primary effect for synthesize and secretions of your glucagon, okay. Now, you guys remember that, it's about like the normal level of glucose in person is about what? Varies for varies, but usually it's about what? Like 70 to like 90 milligram per deciliters, right? So we're talking about the falling level of your glucose level. That's what we're talking about right now, okay? Now, so whenever there is this, there's a glucose level is falling down, okay? There in here, like, look, there's special gene. Remember, in these alpha cells, okay, there's special transporter located here, okay? And this transporter, like, these are GLUT1. Usually this is the one that brings the, glucose into the alpha cells. Remember the beta pancreatic cells, they have a GLUT2 transporters, right? So let's say this brings a glucose molecule right here, okay? Like glucose, that's what they primarily do. And you guys remember this, right? Okay, let me write down this. Instead of writing a glucose, I'll just write a 6, because the glucose is 6 carbon molecules. 1, 2, 3, 4, 5, and 6, right? That's what it is. And then what is going to happen here is that these guys get converted to glucose 6-phosphate, and we're running into a whole pathway of your glycolysis. That's what usually primarily that's what's happening, right? And then you what? And then ultimate result is that what? You go to your Krebs cycles, right? And then you go to electron transport chain, right? And then you what? You produce ATP, right? ATP ratio goes up, and then ADP ratio goes down. Now, that's what usually primarily happening, right? That's what it is. Now, so whenever, let's say, the falling level of glucose is going down, what is going to happen is that, okay, we want to what? Whenever there's a falling level of glucose is going down, this falling level of glucose becomes the primary effect to actually synthesize secrete of glucagon, okay? And just letting you know a little bit of a molecular level, at a chromosome number, let's say, at a chromosome number like 2, okay, the chromosome number 2, they have a gene to synthesize your glucagon, okay? And you guys know this by now, like, whenever they get synthesized, okay, a special locus, you make mRNA. From the mRNA, like, you transcribe into a protein, right? And if you just quickly want to talk about it, okay, let's just make this as a rough endoplasmic reticulums right here, okay, and then because they have these ribosomes, right, let's just make this in a blue color, okay, and then look, let's say this make a ribosomes right here, okay, and then this ribosomes, okay, reads it and then reads the transcriptions code and then start making the protein, right? And for our case, we'll just say this is mine, like pro-glucagon, and then they go to the different cleavage process in your endoplasmic reticulum, and they kind of, get packed and then shipped into, and they kind of butt off, actually. Let's just make this in a black color. They kind of get butt off from here, okay? And this butt off, where does it go? It will butt off and it goes to the, your very, very important organ, right? And this is what Golgi, right? It goes to Golgi, okay? And let's just make this as a here. And they get packed from Golgi's, okay? Further get modified if they need to, right? And then we'll just make this as a, glucagon, okay? And then they will get what? Exocytosis process. Look, let's just make a couple of this glucagon here. Look, there's there's vacuoles, right? And then here, okay, it has this. This is a glucagon right here, okay? What is going to happen to this glucagon? This is going to get what? Exocytosis process. And then what? Whenever there's a low level of, and then it will come. What it will come here? Okay, we'll just make this in a black color actually. Okay, and then it will come. And we'll make a glucagon right here, okay, with this. So now what do we have? So what is that going to go? It's going to go to a circulation right here, right? It's going to go to circulation right here. And here we'll just make we'll make like this glucagon with like bunch of this, okay, with this. And I'll just use this orange. And you guys just remember this as my glucagon. Okay, these are my glucagon. So you just remember this as my glucagon, okay? This is what it is. Now after this, that we have to talk about what is the role of glucagon in a target tissue. That's what we're talking about, okay? One thing that you should always remember is that, your glucagon, the main target for glucagon is your liver, okay? And you need to remember that. The reason why is because, what is glucagon trying to do is that it's trying to what? Trying to mobilize, okay, glucose and bring into the plasma, right? That's what it's trying to do. Because we have a falling level of your glucose, right? And that is because it primarily acts on your liver. That's why glucagon also known as your counter regulatory hormone, okay? Because it mobilizes, or it actually, because of the catabolic, because what it does in the liver is it catabolize, your fats, or let's say, your glycogens. So, and also does gluconeogenesis, okay? So, and brings, with those catabolic processes it does, and brings what? Glucose into plasma, okay? So we call this a counter-regulatory hormone, okay? Here's a peptide hormone, as you guys know, okay? It's a peptide hormone, and I said it's a catabolic hormone, right? Now, what is it? What it does here, okay? Let's talk about this. Your glucagon is now in the circulations. So when it goes to, let's say, liver, or when it goes to the adipose tissues, okay, what is its role there? We'll have to talk about it. But remember one more thing. It's very, very important that, your glucagon, your receptors are not located. It's very, very important, this one. It's not located, okay? Let's write it down in this different color here, okay? Let me write it down in red because it's important. Not located, okay? Not located in muscles or striated. They don't have glucagon receptors are not located in striated muscles, and you should remember that, okay? Not located. That's why I didn't even do this, okay? Now, but remember, the glucagon receptors are a couple of G protein receptors, and you should remember that, okay? G protein receptor here, okay? Let's just talk about it. And this is a G protein because remember, the glucagon is it's composed of 29 amino acids. It has a molecular weight of I think it's 3,485. It's a big molecule, okay? That's why it's a receptor located in your plasma membrane, okay? But this is, as I said, is a couple of what? It's a GS, okay? It is with the GS stimulations. So let's say this glucagon comes here, okay? This is my glucagon right here, look. And this is with the GS protein, okay? Remember, this is GS. And remember, you guys remember this, there's a beta here, and there's also gamma here, right? And then, whenever they give internal stimulations, what is going to happen? This GS is going to be bounced with, okay? Okay, let's just use a different color for here, okay? It's going to go with, GS is going to run with what? Run with ATP, GDP, and this energy molecule. Then it's going to work on where? It's going to work on your special stuff, which is right here. What is this? Let's just make this as adenyl cyclase, right? The domain is going to stimulate the domain of the adenyl cyclase. And let's just make this, okay? And then this adenyl cyclase will do what? You guys remember this by now, right? It will convert your ATP into cyclic AMP. And what does cyclic AMP does? We'll just make it right here. It activates your protein kinase A, right? That's what it does. right? Now, that's what it does. That's why we say this is coupled with the G coupled receptors. Okay, G protein receptor. Now protein kinase is activated. So what does, this is how the glucagon is playing. It's very, very important, right? In the liver. Even on here too, okay? On the adipose tissue, they're also coupled with, okay, let's just say this is my, here, and then 7-pass membrane receptors right here, okay? Like GS, right? And then, same with here, let's say adenine cyclase here, convert the GS, which is bound with GTP, okay? Give a positive here, quickly talking about it, and converts ATP into what? Cyclic AMP, and then cyclic AMP, what it does? Activates your protein kinase. Now what is the role? Okay, because what are we trying to do? Glucose is falling down, we're trying to mobilize the glucose, right? So, because usually whenever there's a high level of glucose, insulin plays roles, and then what do? We're trying to bring in glucose here, right? But, we don't want to bring glucose inside. Actually, we want to, whatever stored glucose is there, we want to bring into the circulations, okay? That's what we're trying to do here. So, first one thing does is that, this, by activating this pathway, this glucagon, what it does is that it started breaking down glycogen. That's what it does, to make more glucose. That's what it does. So glycogenolysis starts. That's what this process is called, glycogenolysis, okay? That's what happens. And not only glucagon, okay? So glucagon has this receptor. Whenever there's like fasting, okay? Or let's say, what else is releasing here, okay? Because whenever plasma level of glucose is falling down, okay? Because you're probably fasting, right? Or you're probably exercising, so you need more energy or glucose. So not only the glucagon, but also like they have a similar function from your epinephrine, okay? And then norepinephrine also, okay? That's extra. And they also, bound with GS pathway, all right? Now, this guy comes, and then what they do is that, okay, look at this is a glycogen, okay? This is a glycogen, and then, look, this is a glucose here, and then there's a glucose 1-phosphate, and then this leading into the formation of glycogen, and this is leading to the breaking down of the glucose 1-phosphate, okay? So what, your protein kinase A does is that, okay, protein kinase A will come, okay, and here, it will phosphorylate this very important enzyme right here. And what is this important enzyme? That we talk about this, okay? This enzyme right here, it's called, okay, phosphorylase. It's called phosphorylase kinase A, okay? That's what it's called. Remember, it's not protein kinase A, it's called phosphorylase kinase A, okay? This phosphorylase kinase A, what it does is that it puts a phosphate group into this guy right here, look. Let's say here, put a phosphate group into it. Okay, so here, this protein kinase A activates this guy, which is a phosphorylase kinase A, and this phosphorylase kinase A phosphorylates this enzyme. What is this enzyme? This is very, very important enzyme. This is called glycogen phosphorylase. What is this called? It's called glycogen phosphorylase. Let's just write down that. It's called glycogen phosphorylase. Okay. Now, not only this guy, once you get activated, also puts another here. Look, this guy. Let's just puts a phosphate group in this guy. Yeah. What is this guy? This is this is your enzyme called glycogen synthase. Okay? Because that's what you're making. Now, just remember this. Okay? So when this glycogen synthase gets phosphorylated, this glycogen synthase becomes inactivated. Let me repeat one more time. Whenever there is a phosphate is attached to the glycogen synthase, it becomes inactivated. Okay, that means when this becomes inactivated, you cannot make glycogen, and we don't want to make glycogen, right? That's why it happens. But when the phosphate group is attached to this glycogen phosphorylase, the activity of this enhances, okay? So what happens is activity of this glycogen phosphorylase enhances, and this start breaking the glycogen, okay, into the glucose 1-phosphate. That's what it does, okay? That's what it does. We're breaking down, okay? And then, look, what is this guy right here? This is enzyme, especially located here, okay? This is called, okay, in the liver, it's called your glucose 6-phosphatase. Okay, it's phosphatase. And it also, okay, putting a phosphate group in it, the protein kinase also put a phosphate group into here, and this activity becomes what? Enhances too, right? So activity of this becomes increased. So what? We start breaking down more into glucose. So this is now we have a glucose. This glucose is going to go right into my circulation right here. We can bring this glucose circulation right here, look. Glucose is right here. Okay, what is this process is called? This process is called glycogenolysis. Okay, so let's just write down. So glucagon, let's write down here. It does, okay, glycogenolysis. That's what it does. Okay, not only does a glycogen, first what it does, it did decrease the glucose uptake. That's what it did, because we don't want that. Okay, so decrease the glycolysis pathway. But it started breaking this glucose by this process called glycogenolysis. And then it decreased what? It decreased glycogenesis, right? Because we don't want to make glucose. That's what it is. So glucagon increases the glycogenolysis process, decreases the glycogenesis process. That's what it is, right?